Hey guys, how's it going? My name is Christian Engel, and today I'll be taking you through how to write the Python code for the application you're looking at and how to deploy it in Streamlit. The application you're looking at is built leveraging the LangChain framework, which is a framework for developing applications powered by language models. And today we'll be using OpenAI's GPT 3.5 Turbo model to accomplish this. The application itself is named Cover Letter Buddy, for now at least, and works in the following way. One, you're going to insert a password of your preference, and the reason why I have this password function is to prevent an abuse of your API calls, which makes sense, it can be costly. And then number two, you're going to insert a company and role of interest. For illustration purposes, let's go with McKinsey and company. And let's say I want to apply for the business analyst role. The last step here is to upload a cover letter. That's going to be a template or something you worked on in the past, and it's going to be the reference point for our LLM to generate a new cover letter. So while it's generating the new cover letter, what's going on behind the scenes is that first, we're going to define a function that first fetches the URL for the company and role you're interested in. Number two, when it has accomplished that, it's going to pass the URL to a second function, which is going to scrape the website for information. Once we accomplish step 1 and 2, we're going to pass this information over to the LLM alongside with the cover letter we upload, which is going to be where the text in the cover letter is going to be extracted and also passed to the LLM. So it has two key pieces of information, and then it's going to be prompted towards passing the applicant tracking system through matching keywords, language, or hard skills or soft skills found in the job description page. And I think this can be of value if you're recruiting and want to get a head start and get a template going. And I think this is a pretty cool application, but I do recommend having a second look at the cover letter and making sure you can vet further information, because it isn't always perfect. Yeah, but with that, let's see what we get here for a cover letter. You can kind of see that first is specifying where we're applying to, which is nice. And I remember from my prior cover letter, I had something similar here in language, but changed it to gain experience working in diverse teams, which is a keyword or two keywords that's found on their website. And you can see how it references to year-long rotation, coaching and training, how to structure ambiguous problems, things that didn't have in my cover letter initially, but it's matching the language found in the McKinsey job description. So it's pretty cool. So if you want to learn how to build this application, follow along and we'll jump to the coding. All right, we're now in the coding part of the project and we'll be using the IDE PyCharm. Which IDE you use does not really matter. And the first thing you need to do is to download the packages, which should be found in the requirements.txt file here. If you don't have them installed, I have them installed on my computer. Please pause the video, and it's important, otherwise you can't run some of the code we're going to be implementing in the project. Great. The first step in this app is going to be writing the function that can fetch a URL based on two input arguments, company and role. We'll be doing this through the help of an LLM, large language model, an agent that we have in LangChain, and a tool. The tool we will be passing to our agent is the Serp API wrapper from LangChain, which will allow the agent to access the internet through Google searches. Before starting to write the code, you'll need to get an API key from Serp API and OpenAI. And if you do not have this from before, pause the video and go and retrieve them. I'll also be adding a link below in the description that you can access to get the Serp API key. Okay. And I'm going to be copying and pasting a lot of code in here just to speed up the process, and I'll be explaining the code along the way. But first, let's define a function that's going to take us from input argument to getting the URL. And we're going to take two input arguments. Number one is going to be the company name. Number two is going to be that specific role of the company. And let's specify this as a string. Great. First step is going to be to paste, for me, my necessary API keys. And I'm going to paste here my Serp API key, and I'm going to paste the OpenAI API key. Also, I'm going to bring in the Serp API wrapper from LangChain. I don't need this part here, which we'll be referencing later as a tool for our agent. Now we want to import the code so we can get our core reasoning engine. It's going to be today GPT 3.5 Turbo. Temperature equals 0. Temperature refers to the randomness of the model, and we wanted to have it fairly consistent. and also takes the last parameter of an OpenAI API key, which we have specified up here. And I want to mention that it isn't a good practice or recommended practice to leave your API keys open like this. You could either use the .env and put it into a gitignore file, but I'm actually going to show you guys something I find more useful, which is using the Streamlit secrets option. And we're going to be doing this toward the end of the video. Now, the next step is going to be adding a template, which will prompt our agent to completing the intended task. And I've already created a template, and for your convenience, I'll just copy paste it here. And feel free to use the same one. The template reads in the following way. Given the company name, I want you to find the URL to their position. Your answer should contain only the URL of the page where the job position is posted. If you can't find the URL, please say so and do not make up an answer. This is very important to incorporate, otherwise the LLM might start hallucinating and giving you bogus links, and we don't want that. And you can also see that we have two dynamic variables, name of company and role. This because it might change based on a user preference, which makes sense. And in order to handle this dynamic variables, we're going to be incorporating the prompt template from LangChain. And the prompt template is a class in LangChain, and it's built to make constructing prompts with dynamic inputs easier. That's all you need to know. And it takes the input variables, name, company, and role, and uses the template you see in front of you. Now, the next step is going to be initializing our agent and defining the tool we want to use. We already know that we're going to use the Serp API wrapper, and I just want to show you the implementation itself. So we're passing a list called tools for agent. We could add many more tools here if we want, but for now we only want to concentrate on the search run function. And I'm going to have the name crawl Google for company job description page, and the description is going to be useful for when you need to get job description page URL. This part is very important because this is where the agent reads what the tool is about. And if you have it misclassified or if you have misused words in language, it might not understand what this tool is designed to do. So very important. The next step is going to be initializing your agent and defining that. And this can be done in the following manner. First, we have our initialization argument. We have the tools we have created up here. Our large language model, which we have defined, and our agent type is going to be the zero-shot React description, which I'll talk a bit more about, and verbose equals true. Verbose is going to show us the thought process of the agent, and this is very good for interpretability. Now, if you are unfamiliar with agents, is on a high level, they use an LLM to determine which actions to take and in what order. So the large language model is their core reasoning engine. An action can either be using a tool, observing its output, or returning a response to the user. There are many agents available in LangChain, and the Zero React description agent uses the React framework, React standing for reasoning and action, to determine which tool to use based solely on the tool's description. Any number of tools can be provided, and the agent requires that the description is provided for each tool, which we have here. And this is going to be very useful for our use case, and I think the zero-shot React description agent is just going to be fine. But feel free to experiment with others too. There's nothing stopping you from doing that. Great, so we do really have all of the necessary components now. The last step is going to be finding our output variable, which we're going to print, and we're going to run our agent. We're going to use our prompt template, which we have up here. We're going to format the prompt by adding in the correct input to these dynamic variables, name of company and role, which is going to be pasted into the template, which is going to be passed to the LLM. Now we can simply call the function lookup, and we're going to specify a company. Let's go with McKinsey and company as we did in the introduction. And let's go with the role equals business analyst. And let's see if we can actually get the URL. I'm going to run this function now. You see it's entering a new agent executor chain. We're seeing this because verbose equals true. Here is the agent's thought process, and you can kind of see that it looks like it has accessed the page, but it didn't find the URL. I can see this is actually language from the page, but it seems to be retrieving a snippet of language versus a link, which could be problematic. And it states that here, instead of hallucinating, it tells us it hasn't been successful in finding the link. And I did a little bit of digging. The code itself is fine, but Serp API wrapper is just not going to work to find the link in its given state. And the main reason for this is that the LangChain developers were envisioning a different use case of the wrapper when they created it. So we're going to modify the source code, which I'll show you here. The syntax isn't all that important, but I just want to show you how it's done and what you're looking at. And followingly, naturally, you're going to have to create our own custom Serp API wrapper. I borrowed this code from another developer. This has been very effective in my cases. Where I've made a change to the source code is here. Before with snippet, and now I changed it to link. So it's getting us a snippet of text as we saw in our terminal, but we want the link really. And all I've done here is I've added my Serp API key to the custom Serp API wrapper, and it's just specified here. So don't worry too much about the syntax, but just remember to add your Serp API key and change this to link from snippet, and we're good to go. Now we're going to define a function as we did with search.run as we had in the prior page. So this function here is now going to be replaced with get job description URL, which takes one input, which is the company name, which is a string. And we're going to run the same code again. The only thing that changes is we're going to pass a new function here to our agent, and we will run it with the same company, and we'll run it with the same role. And hopefully this is going to take care of our problem. So let's run it. Again, we're using verbose equals true. It's entering new agent executor chain. And wow, it got the link immediately. Perfect. So if you want to, you can try and copy pasting this link in your web browser and see if you find the job profile page for McKinsey & Company's business analyst listing. But this will be the first part of our coding session, and we're going to jump over to the next one involving how to scrape the website itself. Now we're going to create our second function, which is the web scraper using a request library from LangChain. Now we're going to take the URL we obtained in the first function to instruct our second function on what website to scrape for information. This step is crucial as the information will be passed to our final large language model call to generate a new cover letter. In order to do that, we'll be leveraging the LangChain LLM request chain when we use the request library to get HTML results from our URL, which comes from the first function, and then we're going to use the LLM to parse the results. We're going to make first a minor change to the code we have from the first function. We're just going to change this to return versus print. And the reason why we do this is so we can return the URL and pass it to the next function. At print, it's not going to work. I've also created a new file called constants. This is where we're going to store our templates going forward. This is because they're going to get bigger and bigger and take up more and more space. And I'll be getting a bit more into the job description template as we go down the code. We've also created a new file called companyscraper.py. Here I have the appropriate packages from LangChain and from constants referring to them, and also have the URL we found in the first function just listed here for demonstration purposes. So let's get into the coding itself. And as in the prior example, I'm going to be pasting some code in and then explaining along the way. But let's define first our function that's going to scrape the URL. I'm going to call it scrape company page, and it's going to take one input, which is going to be the company URL we found in the first function, and that's going to be a string. And we'll be pasting in my OpenAI API key and the large language model we'll be using. Once again, we're using temperature equals 0, model name GPT-3.5 Turbo, and referring to the OpenAI API key. Now, this is one of the most important parts for this specific case, which is the prompt. And I'm going to paste that in here. Prompt. This refers to our prompt template. Reminder, we use the prompt template when we have dynamic input variables. And the dynamic input variable we have here is request results. This here is going to be fetched from the LLM request chain, which I'll talk a bit more about later in the code. But it reads in the following way: please extract key details, including job responsibilities, required qualifications, the company culture, and unique aspects of the company, such as compensation and benefits. And we want this because we can refer to it back in the cover letter that the LLM is going to generate. And we want things to be as specific as possible to the job profile page so we can pass that initial ATS and score very high on the screen. And I'm also saying if the information is not available, please indicate it as not found and do not make up information. This is crucial. We want it to be accurate when we are creating the cover letter. But yes, this is what it looks like so far. Now, the next step is going to be importing the LLM request chain, and I'll explain exactly what's going on here. In the LLM request chain, it first will help us fetch the HTML from our McKinsey URL. And we don't want all of the information, and we don't want it to be outputted in an HTML format. We want the text. So what it does, the request chain, it reads the prompt, and based on that, it extracts the key pieces of information that we want, and it outputs it in a text format into our prompt, which is going to be, again, the request results. And this is one of the key benefits of LangChain. It does it all in one chain instead of multiple steps. And lastly, we just have to specify our large language model and the prompt we are using. Very simple. And we are just going to round off the code by the following pieces of code here. Number one being the input to the function, which is the URL, company URL. We're going to use this one as an example and just look at what we get as an output. I'll just change this to print result, and I'm going to run the function itself. And we're going to input the company URL found in the first one. So let's see what we get. Okay, let's run this, and hopefully we get something interesting. While we're waiting for the output here, what's going on once again is that we're going to extract HTML from the website. We're going to use the LM request chain to get that outputted in the way we want it and extract the key pieces of information that we want to pass to the LM in the final call. It's taking a little bit of time now, but which is understandable given the request we're making. And you can see it outputs it in a very nice and structured format. It gives you first the job title, responsibilities, required qualifications, company culture, etc. And this refers back to our prompt, and this is very, very nice. So that's it for this part of the code. And now we're going to work to consolidating everything into one function and at last deploying a nice Streamlit UI. So stay tuned, and I'll see you in the next section. Okay, now we have our two main functions, and it's time to start to consolidate into one runnable function. And we'll get to do this and be done with the backend part of the project, and then we'll move on to the front end of deploying our app in Streamlit. Now, I went back and did one minor change to the code we did in the company scraper. I changed it from print results to return results. You need to do this so we can pass whatever output we get in this function to the next one here in the consolidator function .py file. Also, I want to take note of what we're importing here. This here is nothing new. We had it in the prior functions, but here we are importing from the website URL fetcher and company scraper the import function lookup. I'm going to have it named company lookup agent in this case. And we're also importing the scrape company page. This is necessary because we're going to refer to both functions in the consolidator, and we're going to get the outputs using them. Also, we have a new import from constants. We have a task description template, which I'll be touching more upon later in the code, but this is going to be the magic piece to get our LLM to create eventually our new cover letter. Let's get into the code itself. So let's start with defining a new function, and this is going to be the function that's going to consolidate everything into one runnable piece. I'm going to call it create cover letter, and it's going to take 3 inputs, first being company, and that's going to be a string, and it's going to take the role as we done in the prior examples, that's going to be a string, and the cover letter, which the user is going to be uploading, and that's going to be a string too. And it might not be so that the cover letter is a string initially, but we're going to convert it to being pure text so we can run it in a final LLM call. Also, I'm going to be copying in a little bit more code to speed up the process. The OpenAI API Key as usual. This function here is going to retrieve the company URL. We're just referring to the function here, and we're filling out the input arguments which are needed to run it. So company equals company and role equals role. And the company and role is going to be clarified in the front end section of this project. But remember, if you look back at the website URL fetcher, You can see it took 2 arguments or input variables, company and role, and we're just putting that back into this function here. The next step is going to be to move on to getting the company data. And this is going to be referred to later as a job description in our prompt template. To get the company data, we're just going to use the scrape company page function, and that takes one input variable, which is going to be the company URL, which we'll get from this function, and we're going to put it back into the company data scrape company page, and this gives us the job description page information with the request chain and everything that we did in the second step. Awesome. And now we have the 2 key pieces to consolidate. Now we want to get back to the prompt template itself. And let me show you where it's coming from. So it's currently named task description template. It's in our constants file. The reason why we have it here alongside the job description template is simple. It's taken up too much space in our regular code file. We wanted to separate it. And I've spent quite a bit of time prompt engineering this part, but feel free to change it. I'm going to go over on a high level here what's going on. So first, I'm telling the LLM to take on the role of a professional cover letter writer with knowledge of the applicant tracking system. Actually, since the model, I believe, was trained until September 2021 with OpenAI, they do have this knowledge, which is great. So we're going to use that to our advantage. Further, it's going to be provided with the job information and the role of the company, and it's going to draw from the company information, job information that we're specifying in our consolidator function, and it's going to look at the existing cover letter. What is it going to do? Well, it's going to identify the skills and qualifications and experiences in the existing cover letter and align it with the requirements and responsibilities in the job description. So as we were talking about in the beginning of the project, here it's really going in and changing action words, keywords, matching the language, and making sure we can score the highest possible in our ATS screening, and also making it to be a very nice cover letter. But I'm not going to spend too much time going over the prompt. Feel free to check it out more thoroughly, and you can change as you see fit. But yeah, let's go over to the function itself and round it up. So we're missing 2 or 3 main parts now. We need to first import our core reasoning engine. It's going to be our LLM, GPT 3.5 Turbo again. And we're going to specify chain, which is the benefit of LangChain. We can run our reasoning engine with our prompt and execute it in 1 line of code. And lastly, we're going to return this chain and the input variables, which we're going to specify in our front end application. But this was the missing piece to our backend function. And now let's go on the fun part, which is the front end, deploying it in Streamlit. Now it's time to begin working on the Streamlit user interface. And here, of course, I'm going to use the Streamlit documentation to build it. One thing I've done so far is create a new front end .py file, and this is going to hold our Streamlit code. And I've imported Streamlit as ST and imported IO and PDF reader. I'm going to use this function here later on in the code. I'll start by pasting an image. And the image here is going to be something I found on Google, which I thought was pretty cool. And I'm going to specify the width as 300. You can change this based on your preference. Then we're going to add a header, and the header is just going to be cover letter body. And you can add whatever you want to add. It really is based on your preference. And we do need to add several input arguments. So we need the company and we're going to need the role. And this can be done in the following manner. We're going to do st.text input, and we're going to say we want the name of company, and we want a placeholder which is going to be equal to enter your preferred company name here. And we're going to do the same for role. And then placeholder, enter your preferred role here. Perfect. So the company and role. Now we need to add where they can upload their cover letter. This can be done with the following code. I'm just going to call it uploaded file is equal to st.file uploader. And this is going to create a button or somewhere they can drop a PDF file, which is going to be their cover letter. I'm just going to say upload your cover letter here. and specify that the type has to be a PDF. This is going to restrict the user to only uploading PDF files, which is what we want. Now I can try and run this, and it's going to give us an error, and it says we have to run this in our terminal. So let's copy this and take it over to the terminal. And it's going to, see, I have a different session running right now. I'm going to stop that and I'm going to run it. What's going to happen on your end right now, and you won't see it on my screen, is that a new web browser is going to pop up automatically and it's going to show us our UI. So I'm going to pause the video here and I'm going to pop up the UI on my end and we can go through it together. So this is what we have so far. We have our image that we uploaded, we have our header, and then we have our name of company, role, and cover letter to upload. And you can type in here, train company. We can add, let's say, data scientist. We can upload any cover letter we want here. And this looks pretty good so far. Yes, it works to upload a cover letter. Perfect. So let's go back into the coding and develop this a bit further. Great. So now we have our company role and we can upload our PDF. But we have to figure out what can we do and how can we extract the information from the PDF file. And it's going to be done in the following way. So I have some code I created here and I'm going to paste it in. And I'm saying if there's an uploaded file, it's not none, we can proceed to the following thing. And this code reads in the following way. It creates a bytes IO object named bytes data by reading the contents of the uploaded file. And then the get value method retrieves the binary data from the uploaded file. And lastly, this line creates a PDF reader object named PDF reader by passing the bytes data to it. And here we have an empty variable, just an empty string text. And this is a loop that iterates over the page of the PDF document in Outlook. It extracts the content from each page, appending it to the text variable. And by the end of the loop, this text variable, which is now empty, will contain the concatenated text from all the pages of the PDF. That's what we want. And to proceed here, we're going to say that if we have and role, and we have the text which refers to the cover letter, I want you to create a spinner. And this spinner is going to be handy because the user might wait for, say, maybe up to a minute or a little bit more. And this is going to be a nice feature to look at while waiting. So yeah, we'll take a bit more through this after finishing up the code here. And I'm going to say that the generated response is going to be equal to the function we have commented out here, which is the create cover letter function. And we do know that the create cover letter function takes 3 arguments or input variables. The first one is company, which I've specified up here. The second one is role, so role equals role, and then we can do cover letter equals text, which is this part here. And this is all going to be passed into the large language model, and it works with this information to construct the cover letter. And then if this is successful, it's just going to be an output message that says your new cover letter has been generated. This so the user knows where we're at in the process and there's less confusion. And we need to specify an output area of text, and this is going to be your new cover letter. And the data that's going to be outputted is a generated response. And let's say the height could be, let's say it should be 400 in this case. Of course, you can change that depending on application. And I also want to add a way for a user to download their new cover letter. And we can do this in the following way. Let's first set a title. So it's going to be download your new cover letter. And I want the data to be the generated response, which is the new cover letter. And we're going to create a file name, and let's be quite logical and straightforward. I'm just going to format this. So I'm going to say cover letter is equal to dynamic variable company, and the dynamic variable row, and it's going to be outputted in adopted text format. And MIME here is going to specify the final format, and that's going to be text, and it's going to be plain text. And you can, of course, change this based on your preference. You could even have it output a PDF if you want that. That's no issue. And we're going to say else, provide them information that you have to upload your PDF file. This should be it for the Streamlit user interface. And let's try and run that. And we're going to have to go back into the terminal and do the streamlit.run. And it's going to open up a new window. And I'm looking at it right now. And from my end, it looks pretty good. Let me show you guys. Here we are. You can see that the UI is still the same, but let's see what happens when we put in some arguments. So I'm going to go with McKinsey and Company. Let's do business. Let's roll. Add a prior cover letter. I'm going to use my old Bain one. And let's see if it starts generating a response. Okay, great. So it's now generating a new cover letter, which is what we want, of course. And if you look at your terminal, well, I'm looking at Streamlit right now, but if you look in your terminal, you can start seeing the thought process of the agent. On my end, it just fetched the URL for the website, and now it's going over to the second function, which is going to be scraping the website for the URL, and then extracting that information and passing it over to the final LLM call alongside with the cover letter, and now it's generating that new one as we're looking at it. Yeah, and here we are. We have a new cover letter, and you can see in the green box here, this refers to the st.success. Your new cover letter has been generated, and let's see what we have. Okay, it looks fairly decent. We have our st.text area we're looking at now, and the height is 400 with the generated response. And you can see we can download our new cover letter here, which is the final feature. And I just downloaded it and I got a text file. So perfect. Now this application is pretty much done, and we're going to finish it up by I'm going to show you how to first deploy it and launch it officially in Streamlit. And I'm also going to show you how to add a security layer by a password function. So I've made a few changes to the code and added that extra security layer. And what I've done is I've removed the OpenAI API key and the Serp API keys. It's not open, you can't see it anymore. Instead, I've added password underscore secret and OpenAI secret, as well as a Serp API secret. So what it's doing here is it's getting the password and it's getting specifically the OpenAI API key from Streamlit. And I'll show you how to add these features, but what's going on in the code is if we're saying that if the password secret is none or the OpenAI secret is none, we can't, it's going to post an error, st.error, saying that secrets are missing, and you just check your secrets configuration. This is going to be a measure for us, so we know that we have to input the secrets before we actually run the app and stream it. And it's going to prompt the user to input a password, and I'm going to show you how to do this part. And it's saying if there's no password inputted, you can reach out to me this email to get it. And the same is it's also for the consolidator function. I've changed, or just for demonstration purposes, we're going to remove this part, and we're going to do the same thing here. So I'll ask for the website URL fetcher. For the Serp API key, I've added instead this function here. Good. And with that, let's run this again and see how it looks in Streamlit. So back to the terminal, and let's restart it. Now we've added the layer of protection, and this is what your app should be looking like. And let's go ahead and insert a password. Okay, I didn't insert the right one. It says reach out to me over email. Okay, and there we go. I log into the app. I use the password 123456, and everything else looks the same. But we have that extra layer of protection, and now it is time to deploy the app. So let's exit this for now. First thing you have to do is go to GitHub and post all your code, create a new repository. Since we're going to be pulling from this repository to create the Streamlit app. Only minor thing I've done here of change is to consolidate the create cover letter and the main Streamlit user interface. I've just created a function here that has the exact same layout as the prior one, but I've just added into one file. This is my preference. You don't have to do that, but this is what I have for now. So let's go to Streamlit. And in Streamlit, if you don't have a user, this is a good time to create one now. Let's click on New App, and we're going to deploy an app using an existing GitHub repo. You have to click the main code file, which for me is app.py, and it's going to pull from that. I'll paste it in, and it takes the main branch and the main file path, and we can deploy. So while we're deploying, it's running the code, it's checking everything and seeing if it makes sense. Also, here it's important that we go into settings, and we're going to add our keys that we're going to be pulling from, which refers to the extra layer of security we just added to our code. And for me, it's going to be pasted in the following format. The password is going to be 123456. OpenAI API key is this one, and the Serp API key is this one. We're going to save, and bear in mind that is when we do the .get function, this is what we're pulling from first. So it specifies we want to get it from our password, and then it's going to retrieve the key afterward, which is this part, or the password here. And the same happens for OpenAI as well as Serp API, and you just have to save it. So this makes sense. We have a required secrets are missing, and please check your configurations. We just added them, so now we can log in. We'll type in the password, which was 123456, and here we are. Enter our company name, and we can start producing our new cover letter. And this is it for this video. If you have any questions, drop a comment below, and I'll add some more descriptions as well as posting this code or sharing the GitHub repo with you if you want to copy and paste it in while following along. Hope you enjoyed it, and there'll be more to come of content, so please stay tuned and subscribe.